Awesome. I believe folks can put stuff in the chat. So maybe you guys can throw in where you're calling from today. Can you guys access the chat? Oh,
Oh,
chat is
Travis
disabled.
says the chat is disabled.
All right, let's figure that out.
We're live on YouTube and X.
Okay. And attendees can chat with everyone. Panelists can chat with everyone. So try and put where you're calling from today in the chat. Nice.
Ooh, there we go.
Hello. Nice. Nice. Very cool.
Nice. West Coast, best coast.
There's people from Oregon, Seattle.
Esplin's in Utah, and I'm in Seattle.
Yeah, where are
So
my
it's all West
Utahns?
Coast.
Come on, Utahns.
How do you spell
Everyone,
Utahns? How does that spelled?
just put an N. Just put an N between the H and the S. It's literally what they
Oh,
do. What we do, I guess.
Utahn. Nice. Oh, cool, Travis. What company are you from? Trying to remember a Travis. Ah, okay, okay. Very cool. Nice. Well, thanks for coming by.
We'll give it a few more minutes just to give folks a chance to join, but let's plan to start at 5:05 or 5:05 Eastern.
Yeah, that's the big question. How long to wait? 5 minutes. Like it.
Mm-hmm.
As you can tell, we're very good at crowd work, keeping people engaged.
Oh, welcome, Flavio. Great to see you. Mm-mm.
Cool, Travis. Nice to come across you again. Um, appreciate you joining. Hey, Flavio. Nice to meet you. Flavio, where are you based? Ooh, nice. London. It's pretty late there, huh? What, like 9 p.m. or something at least? Oh, 10 p.m. Wow.
Yeah, pretty late.
You
Hey,
sing some
Rich.
lullabies at the end. I nominate Jay to sing the lullaby.
Oh, I'm down. Yeah. If you stay through the whole thing, I'll sing a song at the end. Feel like we should have some cool elevator music, you know?
Mm.
Maybe next time.
Yeah. Some logistical things though. There's going to be Q&A, so if at any point you have a question, Zoom Q&A to ask away, we'll be checking in on that periodically. Other than that, we're going to start in about a minute here.
How are the streams coming along? Oh, nice. We
Everything
have
is working. First try. Kind of
we have
excited.
14 viewers on Twitter.
And I am the only person watching on YouTube.
Fair enough. Fair enough.
I think I know why too.
Okay, cool. Looks like we have a good group of folks in Zoom and on Twitter. Maybe we'll get started now. Vadim,
Let's do
Esplin, that sound good?
Sounds great.
Okay, cool, guys. Um, Thank you for coming to Highlight's first official live stream. Today we're going to be talking about distributed tracing in Next.js. And yeah, we hope that you'll enjoy it. And as Vadim was saying throughout the presentation, we'll have Q&A. So definitely stick questions in the chat as they come up. Um, we have some cool stuff prepared to show you all. So we're really excited. And yeah, thanks again for coming. Um, without further ado, let's get started. Cool. So just a quick round of intros. My name is Jay. I am the CEO and one of the co-founders here at Highlight. I run sales and product for the most part. Over to Vadim.
Yeah, and I'm Vadim. I'm the CTO and run the engineering team here at Highlight.
And then
And
Esplin?
Esplin.
I'm Chris, an engineer at Highlight, working at the JavaScript SDKs, particularly this Next SDK. And I do podcast and media stuff.
Cool. Thanks, Esplin. Um, and so yeah, in terms of today, I think what we're planning to go over are a handful of topics. The first is we'll talk about just general Next.js architectures and how the sort of common modern Next.js app is built. The second thing we'll be going over is just distributed tracing and how you can connect the front end of your Next.js application to the server side and then to any downstream services from there. The third thing we'll be talking about is an actual example application and like sort of more tactical advice on instrumenting those applications with respect to distributed tracing. And then we'll finish things off with just a demo against a sample environment. For that sample environment, we'll actually use the highlight.io application. I'm sure that folks listening are familiar with that, but it's essentially like an open source monitoring distribution. That's the company that we work at. And it will be a nice way to just see those traces in action. Um, so yeah, without further ado, let's get started. So what is distributed tracing? When we think about distributed tracing at Highlight, we think of basically performance monitoring and actually understanding a complex distributed code base. So let's say you have several microservices, maybe in the more traditional sense, that are talking to each other. You will want to be able to trace what data is going from one microservice to another, and then how long those respective operations take. This can be useful from like a performance perspective, right? So if I look at one of these services and I see that they're particularly slow, I can kind of look into why that slowness is happening. But it also can be useful for like monitoring other sort of observability resources like errors and actually connecting those to user sessions, so on and so forth. So in general, tracing is all about performance, but it has a lot of implications when it comes to other observability resources in your stack. We'll go over to the next slide, which is talks about the goal for today's presentation. So, and I'll let Vadim, yeah, take that. Sorry.
Yeah. So let's talk a little bit about an example why distributed tracing is useful for us. So here we're looking at a front-end application making a network request to the first server-side application. And that server-side app is then making some other calls to distributed systems. Now, you might have a dozen different services that all are responsible for different things that are all behind your own VPC or otherwise internal. And you just have one that's exposed to the web application. That one handles authentication, handles the user context, anything else specific to this front end. Distributed tracing allows us to bring all that scattered information into one view so that you can understand exactly what code was running on these different applications, on these different services, and how it all stitched together to impact this particular user. And it's important to stitch all that together with network requests using something like an HTTP header, but there's other ways to do that too. But in general, distributed tracing allows us to just debug and understand this code execution better across different services. And so Next.js is a particularly good use case for this. I'll hand it over to Esplin to talk a little bit about why.
All right. So Next.js is often set up kind of as a backend for front end. Next.js has its own whole Node backend system, but it's limited because it's Node. It's not Rust, Go, or C++. And so what's a very common architecture is to have the next API serve the next front end, and then the next API make calls to all your other services that you've got at your company. It's a super common system. Architecture, I would suggest, is probably the most common way that Next is used.
Thanks, Esplin. And so now we'll kind of go over to what it looks like with respect to an application. So in terms of like like we're I guess talking in a little bit of abstract in terms of what distributed tracing is and the Next.js architectures, but here in front of us we have an actual example of what that application might look like. So on the left we have like a front end, and let's say that this is like the front end, like the client side logic that runs in your Next.js app. In the center, we have a server runtime that is also Next.js. So it could run in like the Edge runtime, it could run on the Lambda, but it's also part of the Next.js framework. And then on the right, we actually have a Go microservice that is getting called from that Next.js backend. Now, the important thing and what we'll be focusing on a lot today is how we can pass data from the front end to that first backend and then to all the rest of the downstream services. And the short answer there is it's all in trace headers. At the bottom of this slide, there's actually a link, and maybe I'll have Esplin or Vadim share this in the chat. There's a link to the GitHub repo that we'll be using for the rest of the example. But yeah, in general, like we actually will have an example that you guys can follow after the fact if you guys want to actually get this set up, which instruments the front end to the server of Next.js and then to all those downstream traces. So with that, I will move it over to Esplin on kind of what the first step looks like with respect to getting this set up.
So your first step is to pull in our Next.js client SDK. And you can see this import here. We're importing highlight init on line 3. And then we're injecting it into our root layout of our next application. And so we can pass in all the different config we would typically pass into highlight. And the one to watch out for here is tracing origins, turns on our tracing. And let's go to the next slide. Once that's in place,
I think we might
do we
have the
have
wrong
the next
tier.
slide? Yeah. Was that it?
Yeah.
Okay. All right. Then all XHR and fetch requests will then get proxied correctly and have the correct headers from the client that can then go to the server and we can then proxy all the way through.
Cool. And so yeah, just to kind of comment on what the like just the need for those examples that Esplin just talked about. Essentially, what that's doing is allowing us to add a trace header to all the outgoing requests. That way, for the next steps and what we're going to be about to talk about, we can catch those headers on the server of Next.js to then forward them moving forward. So we just went through what the client side setup looks like. And I will now move it over to Vadim to kind of talk quickly about distributed tracing with respect to a little bit of the vocabulary we use when we're talking about this kind of stuff.
Yeah, for sure. So we talk about a trace, we also talk about spans. So when we talk about a trace, we mean the entire context all the way from the browser, from the client side, to all of the distributed services that are running under the hood. And a span is each one of the individual code blocks that are instrumented. So a span is like one particular function or one particular API operation, but some specific subset of your code that's running that's grouped together logically, kind of like a function, right? So It's important to note that here because the spans can be running across different services, and what ties all of them together is the concept of the trace. So the trace originates from the client and then persists for the entire distributed session here across all of the individual microservices that might be getting called. And within one microservice, that trace is still the same, and so all the spans are associated back to that particular trace. And so the way that we typically associate that information is using the W3C specification of trace parent and trace state. So W3C is just an open source way to define how to connect all that information across different services. So if service A is making an HTTP request to service B, in order to continue that trace along, you need to send that trace ID with the request to the downstream service. And there's a little bit more to that. So we don't just want to propagate the trace ID. We also need to propagate context around who the parent of your particular span is so that things can be associated correctly across different distributed systems where timing might not be consistent. So for example, this might be service A or like system A running on one machine, and now everything below this is running on a different machine. These machines might have different clock systems. So in order to understand that this code block was executed by service A, there's a little bit more that gets passed around via those headers. But in general, that's encompassed by this W3C specification for how to propagate it. They also support other ways. So if you're thinking about like a Kafka queue or some other way to distribute work between different machines, you can propagate that same information with the OpenTelemetry native support. And on our SDK side, we support that out of the box using OpenTelemetry. We also support our own X-Highlight request header, which is just something we use for our JavaScript browser client that's not necessarily OpenTelemetry. That way we can, on the back end, still associate things to a network request, to that trace, and to a session, but it's the same concept. So with that, I'll pass it back to Esplin to connect the next part of our instrumentation to show how we're capturing that request from the browser on the Next.js side.
Yeah, so
And
here
maybe
we
before that,
see, yeah.
let's just quickly pause for questions. Does anyone have any questions in the audience in terms of what Vadim just went over or what Esplin went over on the client side? Um,
Looks like we had one question from Travis around page router support. So specific to Next.js, does OpenTelemetry or the Highlight SDK support page routers? Esplin, do you want to
Yes.
elaborate some more on that?
Yeah, we support page router and app router, and we support it across the Edge and Node.js runtimes. The one spot where we don't have great tracing is SSR tracing. We do catch SSR errors. Um, and on, but yeah, it's SSR. That's our only real hole right now, and that's just because Next.js doesn't really support that. Doesn't give us enough request data to then transmit it.
And I think to
and I
clarify there, for SSR and ISR, we still can capture Next.js spans that are emitted by Next.js. We just don't necessarily associate them with the front end session because it's a little bit harder when the request is initiated by the server. Is that right?
Yeah. Yeah, the headers don't come through. We can't capture them and attach them, but we can just catch everything. Yeah.
Cool. Any other
cool.
questions? And feel free to keep posting stuff in the Q&A as things come up.
Awesome.
So
Okay, cool. With that, I will, yeah, move it over to Esplin on step 2 in the instrumentation process. My bad.
yes, you'll notice here that we're in this is the app router, but it could be page router. And we're using app router highlight. That's from the highlight run next server package. And we're using that to create a function called with app router highlight. So we do our initialization. Now we've got this wrapper function that we can wrap all of our API endpoints with. All right, next slide. Here you see we're wrapping a GET request with the app router highlight. Okay. And we're about to make a call to localhost port 3010/test method get with the headers. And the key is we're passing the headers along. If you wrap your handler with app router highlight, all the headers will then be attached to that request headers. So when you pass those along on line 10 here with request.headers, the X highlight request header and any trace parent or trace state headers that you've attached will now flow all the way through to your next call.
Awesome. Awesome. Cool. So yeah, I guess at this point to just kind of give ourselves an update on where we are in this like three-step process. We are sending trace headers from the client through highlight instrumentation to the server. And then at that point, we are basically patching headers to outgoing fetch calls using the W3C spec. That way, these traces kind of can start to propagate through the rest of our services. So we're almost the way there. And as you can see, kind of in Next.js, we'll have to manually add that header. So that's something to keep in mind and to yeah, keep in mind when we're sending this to like third-party services, that we send those headers. That way, if there are respective OpenTelemetry SDKs receiving the headers on those services, they kind of go through as well. Um, and so
And
I
that's a
guess,
really
yeah,
good point. Really good point, Jay, because some languages are simpler than others in that sense. So, for example, in Python, OpenTelemetry automatically will propagate the trace context using that W3C propagation to other downstream API requests if you're using the requests library, or even if you're using something like Celery to queue tasks via Kafka or RabbitMQ. OpenTelemetry will automatically inject that trace parent and all the rest of the information into the messages or into the requests there.
thanks, Vadim. Thanks, Vadim. Um, cool. And then I guess I did just ask for questions, but if there are any others, we can kind of just do a quick gut check on that end. Seems like we're good. Um, cool. Awesome. So let's keep going. The next thing that we will talk about is sort of this step three, where with on a third-party microservice, if we're calling meaning it's not Next.js, how are we supposed to accept these headers and then further forward them over to any other services, so on and so forth? Vadim, all you.
So on that note, our example here is actually a Go application. So when Esplin was talking about our next API route, making a request to port 310/test, that would be hitting this Go application that's running. Go with OpenTelemetry and just the nature of Go, it's a little bit harder to magically inject the context and grab things from the HTTP request. So we needed to do a little bit more work to get traces to be emitted. And same thing with the OpenTelemetry SDK. There's a little bit more setup that you have to do. But in short, with a router like Chi or some other way to organize your HTTP server, you can add a middleware that will intercept every single request that your server gets. And that middleware will look for HTTP headers to look for that trace parent, trace state, or our custom X highlight request header. And when we receive that, we will add it to the context for the current handler. So /test with Chi, just a little bit of context on Chi. Every route has a function that's the handler for that particular route. And our middleware will wrap the invocation of the handler with the trace creation and trace end. So every single thing or every single route that your server is executing that code will be wrapped with a span. And here on line 46, we're also creating another span so that we can have a span that's for a subset of our code. So let's say, for example, you make a SQL query or you have some other slow operation as part of your route. You can instrument down to a single line of code to understand how long that particular operation took out of the full context. So all of that is just to say that now all of these spans with our middleware are going to be capturing the incoming request headers and associating everything with the same trace. So again, everything gets linked back together. And with that, I have another slide here, a little bit more on W3C propagation. So what that incoming request might look like with that specification, we would have a trace parent header that, let me annotate here. This longer portion of the string right here is encompassing the trace ID. So that's the initial request from the client side, just a unique generated ID there. And we have the trace parent right here. That's the ID of the span that called us, just so that we have exact hierarchy and we don't have to rely on timing or some other less precise way to know who called us. There's a little bit more that can be passed along with this trace state. And if you're curious, the OpenTelemetry protocol has this concept of baggage, which is the ability to add other metadata to your request. So let's say, for example, there's something else that's maybe structured data or something else that needs to get passed along with the trace ID. You can pass that along and propagate it with the baggage concept, and OpenTelemetry makes it pretty flexible to define serialization and deserialization for that baggage. So that it's agnostic whether you're using HTTP, gRPC, or some message queuing system like Kafka or Redis. Any of that can hold that additional context.
Thanks, Vadim. Cool. So at this point, we have um, gone through the 3 steps to get this type of thing instrumented. Just to kind of like do a last pass here. Now our client monkey patches requests that are going out to the server and adds X highlight request headers. The Next.js backend consumes those headers and then forwards over W3C context headers, which is sort of the common OpenTelemetry spec for these trace headers, to other services. And then our Go backend consumes those services and forwards those same headers off to any other respective services that they're talking to. So that this kind of gives us a full picture of what the life cycle of a given request might look like. But it's a little abstract, right? Like we are not actually seeing what this looks like in terms of on our actual product. So with that, I am going to turn it over to Esplin to show us what this sort of looks like on the highlight dashboard if we were to do this. Before I go there, I do want to kind of quickly mention that, as much as this, we are touting our own product, right? Like we're showing you our product because we do think our product is good. This is relevant for other sort of observability vendors you might be using, things like Jaeger or New Relic. There are other products that kind of allow for this as well. And the nice thing about kind of the presentation so far is that for the most part, these are open source specifications that will move to other like vendor environments. So just something to keep in mind when we're kind of giving this presentation is that it's relatively greenfield and will work elsewhere as well.
And one thing to add there, Jay, is OpenTelemetry is great because you might have different parts of your ecosystem at a larger enterprise where different services are kind of like black boxes from the outside. But it's nice when all of them use the same specification and it's an open source specification like OpenTelemetry or W3C trace propagation, because then it just means that that's just one less thing you have to worry about. And you know that it's the same language that's spoken across all these different services, regardless of how they're implemented or what frameworks they use. So just kind of another reason that OpenTelemetry is so great for something like this, regardless of the visualization platform or the storage layer you use to store all this data.
Thanks, Vadim. Cool. So over to Esplin with that on what this sort of looks like in highlight.
Okay. So you can see we have 4 different lines here, and they're all in order. So starting from the bottom, you have highlight run with headers. That was our span coming out of the Next.js API GET request. Also that fetch, you can see just above that, it shows that the fetch is going out to /test. Then highlight chi starts a header, and then our go custom span is another, those are 4 separate spans. And if you look to the right, you'll notice that we have the same secure session ID across all of them because it was passed through with the headers. All right, so let's go to the next. Yeah, there we go. So now we have the pane popped out, and you can see the highlight run with headers. It took us 1 second and 20 milliseconds. And you can see the rest of sort of in context with all the rest of the spans that were attached to that trace. And here you go. You can see the end, your Go custom span shows itself again within the context of all of those. So you have full context across the entire call stack.
And the nice thing here too is that every one of the spans can have its own structured metadata sent along with it. So in this case, you can see down under this metadata panel, highlight will be showing you all of the attributes that you send over. So in this case, custom property was something that Chris added to that custom span. So when we emitted the custom span, this could be just a numeric structured attribute or any other sort of uh, additional context useful for debugging this span. So if we're trying to say, why did the span take so long? Why did it take a whole second to run? Maybe it was a particular SQL query that was slow with given arguments that resulted in missing an index or having to query a lot of data. There's so much more information that you can get with this sort of information. But then the flame graph at a high level lets you jump to the important part of your code execution right away in terms of identifying an error or identifying the performance bottleneck.
Awesome. Awesome. Any questions so far on like the product side of things and maybe how tracing is incorporated into Highlight? I think Travis's answer is answered. Um, I think we're good on this end. Um, cool. Well, I guess with that, that kind of covers what tracing looks like in the context of, I guess, a modern Next.js application. In terms of sort of next steps, I would encourage a couple things. First of all, we did link a few things in the in the chat. Um, and maybe we can send this as sort of a metadata on the actual event that you guys signed up for future reference. But in addition to that, what I do recommend taking a look at is just the OTel docs for any non-Next.js related SDKs that you're working with. That'll make it really easy again, kind of similar to this example, to connect a Next.js framework instrumented with Highlight to the respective microservices that are in those languages. Um, we also encourage you to take a look at Highlight. No bias there. But yeah, beyond that, I feel like that's kind of where we are at this point. I feel like we enjoyed having this conversation. Thank you for coming. Um, anything I'm missing, Vadim or Asplin?
Nothing on the content. We're going to be making this more of a regular thing, so stay tuned for more. We have some exciting content on OpenTelemetry for WebJS and for the client, for the browser side, as something we're thinking about and a lot more on that end. So
And
definitely
then
some more. Subscribe to our YouTube channel for more information there.
and actually, like even in the more short term, in about a month, I think we'll be doing a live stream again on OpenTelemetry in Next.js exclusively. So it'll be going over how if you didn't want to use Highlight SDKs or whatever other SDKs you're using, how you can just instrument Next.js to send OTel data. So yeah, keep keep yourselves in the loop. We'll definitely make sure to get in touch on those notes. And yeah, thank you for your time.
That's it.
Thank you, folks.